One recording started at least. So it's a special day today because it's the start of presentation season. So we have a formative assessment to go over, and then it will be Presentationville for the next several classes. As a reminder, your peer review feedback for each group is due the Wednesday after that week. So whoever's doing Carl's peer review, that will be due Wednesday. Whoever's doing those for their presentations on Thursday, who's going on Thursday? You know? Those two, and there's probably one more, and I don't remember who it is off the top of my head, but Thursday the class will be sparsely attended because of NCME and AERA. Everyone is leaving town. So if not many people here are here for your presentation on Thursday, don't take it personally. It's not a coincidence that I'm scheduling the non-ed people for this week since everyone else is leaving for the most part. So let's see. I updated grades this morning, including the extra 3 points for the quizzes, so you have 9 points if you've done all 3 of them. We have some answers to go over, and then I will turn the show over to our first presenter. As a reminder, I need your presentation files by 10 a.m. the day you are scheduled. You can either email me a PowerPoint, or if you want to send me a link to where I can download it if the file is really big and you don't want to clog up your email. Or if you're going to do an HTML presentation or whatever, just it needs to be something that I can load on my computer so that I can keep the Zoom connection and the recording connection and all this stuff happening. So let's see here. First question on formative assessment number 3 then. What is the problem of a smushed effect, and what are 3 strategies for preventing it? I looked at your answers this morning, did not have a lot of time to give detailed feedback, but it seemed like most people got the hang of this. So if I say smushed effect, what am I talking about?
The between and the within parts have not been disentangled. Like you're getting something that's accounting for both instead of one or the other.
Yes, the between and within sources of variation in a predictor have not been given separate slopes in the model. And so the one slope that they get is commingled with both. Usually it's going to be closer to the within slope because there's more information at that level, but it will be biased to at least some extent. And if you feel silly writing smushed effect in your papers, what is a more formal way you can express this idea? Conflated. Yeah, that's my personal favorite. Other ones are composite or convergence. Composite to me could be a lot of different things. Conflated is the one I would probably go with because that I think is a nicer way to say smushed. And strategies for solving it then. What do we do? There's 3 choices. Person mean centering. And if we do person mean centering, what do we get? Oh, not sharing the screen yet. Sorry, Zoomers. I'm on the quiz, though, so you can play along. Thank you for the reminder. All right, person mean centering. If I do that, what do I get back? That's it. Level 1, it only has within level information. It can only provide a within slope. Level 2 only has between information. It can only provide a between slope. The end. Option 2. Yeah, grand mean or constant mean centering with what included with it, though?
With the within.
How do I get to the within slope? What else has to go into the model with the constant centered level 1 predictor? Yes, the level 2 mean. So if you just enter the level 1 slope variable all by itself, that slope is smushed. To unsmush it, we need the level 2 mean to go with it, and that becomes the contextual effect. So then the separation doesn't happen in terms of the variable's information. It happens in terms of their effects through statistical parceling after that, partialing. I never say that word correctly in the first try. Third option.
Latent.
Yep, that's one word for it. If you were to explain it, what does it do?
Pretend predictors are outcomes.
Yep.
So that you can divvy up the variance with the model.
Yep, let the model figure it out. So we tell it that the predictor is an outcome, and then we let the model partition its variability. So the analog of within person-centered variable in person mean centering becomes the level 1 residual variance for that predictor. The analog of the person mean level 2 predictor becomes its random intercept variance. That is only going to have a separate estimated variance at level 1, by the way, if you have a normally distributed outcome. So if you have a binary outcome, ordinal outcome, there is no separate estimated level 1 variance. You can use the corresponding link function approximation, though, for it. So if you're in logits, for instance, you can plug in 3.29 for what the residual variance would be at level 1. If you're in probits, it's 1. If you're in some other kind of like log link or something, there's not an easy translation for that because it's non-constant variance. Yeah, so those are the 3 main strategies. Any questions or comments about that? No? Okay, moving on then. Number 2. When centering an observed time-varying predictor at a constant, grand mean, 0, whatever you like, what does its slope represent when included without the person mean? So the slope of the level 1 predictor, if I just put in that all by itself, what do I get? That's smushed. And what do I get back after I include the level 2 mean? Then it's within. Yep. And several of you commented about interaction terms. The same thing happens. So if I have a level 1 predictor times x, then I need to have the level 2 mean times x to unsmush that interaction. It works the same way. Good. Number 3. What are 2 ways you can tell if you're reading a paper that you're dealing with smushed effects?
If they don't tell you what's level 1 and level 2, like
Yeah.
you can't tell how they've unsmushed.
If they don't discuss it, if they're just like, here's my time varying predictor, the end, that's a good sign. So if you're looking at a table of results, for instance, and there's no level 2 version of each level 2 predictor, or they didn't explicitly say that they within centered first, which is another option to remove the level 2 variability. What about explained variance? How could a smushed effect be detected via reporting R squares or things like that?
If level 1 and level 2 pseudo R squareds like change when you only put one variable in.
Yep.
There has to be the 2 components of variance within that variable.
Exactly. If I enter a level 2 predictor in the model and it reduces my level 1 predictor in the model and it reduces my level 2 random intercept variance, it was the level 2 part of the level 1 predictor that reduced the level 2 random intercept variance. That's a smushed effect. And the problem is that it may not be the right level 2 effect. It's whatever the smushed effect says it would be, which may be too big, too small, or even in the wrong direction. So if the level 2 variance changes, it goes down after you enter a level 1 predictor. That's a sign of a smushed effect. What about an SEM? Several of you commented on this. If I have a single level structural equation model involving time varying predictors, how can I tell that I am dealing with smushed effects? Remember the pictures? You have a row of boxes? Yeah. Question or answer? Am I hallucinating? I thought I heard someone start talking. Maybe just a mic fail, who knows? Remember the row of boxes? Time varying predictors going to the other outcomes, and if those row of boxes don't have any intercepts and slopes attached to them, those are smushed effects, unless they covary with the intercept and slope of y. There's a weird catch to that. If the time varying predictor boxes are brought into the likelihood and they covary with the intercept and or slope factor of the other outcome, then those paths are within only. But the reason I still wouldn't do it that way is that you don't have access to the separate between effect. In order to get the between effect, you would need an intercept variance for the predictor at a minimum that can then relate to the intercept variance and the slope variance of the other variables in the model, or be predicted, as it were. So it's less obvious, I would say, in the world of single level SEM when you're dealing with smushed effects. You have to do a little bit of detective work. But generally speaking, any variable that's measured over time is probably going to have level 2 variation in it that needs to be represented in the model somehow, a box or a circle. And then, if a time-varying predictor contains individual differences in change, so the predictor itself changes differently over people as a function of time, can I do person mean centering or constant centering for it in a univariate approach? I cannot. Why can't I?
Because there's more than one kind of between person and cell.
Exactly right. So the idea that the person mean covers the between is an incomplete coverage if another type of between is individual differences and change over time. There is no good way to create a box to do that. If you output slopes from individual regression models, those slopes need to have the residuals attached to them, otherwise they look like they're too good. At the end of chapter 9, I have an example of what it would look like if you tried to do that and you don't get the right answers back. So it's not a good idea to output slopes. You want to avoid that by doing a simultaneous analysis if possible. And that's where you enter the world of what is multivariate growth curves or multi-level SEM. Basically, you have more than one variable being partitioned into between intercept, between time slope, and within residual at the same time, which is where most of you are for your projects. And it's trickier than it appears, isn't it? Yes. So I don't think there's a single person whose model worked on the first try. So if you're feeling like, I should know how to do this already, you are in good company. And that is part of the exercise here, is learning how to fight with M+ or R or whatever package you're fighting with and succeed. So folks who are having models that take a long time to converge, I've given this tip several times. The option in M+ that you can add to the output is S values, one word. What that does is recreate all of your model input code and attach starting values based on where it finished in the last run. So then you can literally copy that code, put it in a new input file, and then you've fed start values in. That should hopefully facilitate estimation. In particular, the level 2 random effect variances and covariances. Those would be the things that need start values. Also in latent basis models, any estimated factor loadings for change, start values will help those as well. So if you're tried all of that and it's not working, make sure M+ is reading your data correctly. You may have accidentally forgotten like one of your names of your variables and it's off a row or off a column. That happens. It spits out univariate descriptive statistics as the first part of the output, and so you can tell based on that, like if your means and ranges are in line. If not, if it's not reading the data, that could be the first problem. So that happens more often than you would think because there's no way to visualize what the data set looks like from inside M+. You can't like click it and see that it looks correct. So a little bit of detective work. All right, so multivariate is the answer to this. What if the time-varying predictor has fixed change only? So everybody changes the same, but there is some degree of constant change. Then can I do person mean centering or grand mean centering if I want to? What do you think?
No.
You say no? Why not?
Oh my gosh, my brain is blanking. I know you have to switch over to multivariate software. Because you have to make latent factors. Is this the structured residual thing? No.
Structured residuals is when you need to change your level 2 slopes from contextual to between. That's what structured residuals are for. So that's another thing, but not directly related to the question. If the time-varying predictor has fixed changed only. So there is change on it, but everybody changes the same. Then is person mean centering or constant centering an acceptable solution? I'd say yeah, in that case. Because once you put in a fixed effect of time in predicting the outcome, the time-varying predictors is the unique effect after controlling for time. It's like you've detrended it. So you've detrended it on average. Where the problem comes in is that the random slope that's in the model for the outcome is not necessarily the random slope your predictor would need. It's a different variable. So you can't control for change on an individual basis by having a random slope predict the outcome. You would need a separate random time slope to predict the predictor. So reasons that you might not want to do it that way: it's supposed to be a better estimate of your level 2 relationships if it comes from a random intercept rather than a person mean box. For the same reason that we don't want to use observed variables, we want to use latent variables if we can to try and correct for measurement error. At the same time, though, the results tend to be a little more unstable, and adding things like moderation for interaction terms is trickier if you have latent variables than observed variables. So pros and cons, but I want you to have a full suite of choices available to you. All right, 107. Didn't ramble too much. Want to make sure we have enough time. Any questions or things that you want to talk about related to this formative assessment or otherwise? No, we're all traumatized, aren't we? I hear you. It is not different on my end. It's just we're traumatized by different things.